These notes are on classifying triangles. And we're going to start by classifying by angles. When you have three acute angles, three angles that are less than 90, you have an acute triangle. When you have a triangle that has an obtuse angle, you're going to have an obtuse triangle. When you have a right angle, of course, that's a right triangle. I'm just abbreviating. And then when you have three congruent angles, when they are equal, it's called an equiangular triangle. So let's, using the diagram, classify each triangle by its angles. Let's take a look at CDE. CDE is this triangle here, and I'm going to go ahead and use my highlighter. C to D to E. We can see that this triangle has a right angle. So this is a right triangle. All right, our next one to classify is triangle BCE. B to C to E. This triangle has one obtuse angle. And remember, an obtuse angle is greater than 90. We can see that right here we've got at angle C an obtuse angle. So this is an obtuse triangle. Triangle ABE is the next one we're going to look at. A to B to E has three angles, and these markings indicate that these are congruent. With three congruent angles, we have an equiangular. All right, next up is BDE. So starting with B, go to D, and to E. Okay, what I'm looking at now is also an obtuse triangle. See how it's greater than 90? In fact, we can see that this would be a 90, but we've got more than 90. And so this is another obtuse triangle. Okay, next up is going to be CFE. So start at C, go to F, then to E. Now, you might think that this right angle is part of it, but it's not. There's actually a little space right in here. So this is an acute angle, another acute angle, and yet a third acute angle. When all the angles are acute, we have an acute triangle. All right, so now let's classify by sides. Three congruent sides is equilateral. When you have two congruent sides, you have an isosceles triangle. And when you have zero congruent sides, this is a scalene. So three congruent sides is equilateral, two is isosceles, and none is a scalene. So again, let's classify each triangle by its sides. And I'll use my highlighter again. JKM, J to K to M is this big triangle here. All right, so let's see, what do we have here? We are looking at three different side lengths. Three different side lengths makes a scalene triangle. Next up is KLN, so from K to L to N. Now the difference with this triangle and the first one are these little markings. These little two hash marks indicate that these sides are congruent. Side KL and side LN. Those are congruent. If we have two congruent sides, we have an isosceles. Now the third side does have a congruent marking, but see how it just has one dash? That's different than these two dashes. This one dash is not congruent to the two dashes, only to other one dashes. Our last triangle, JKN, J to K to N. And we can see on this triangle that we have three of those congruency markings, so this is an equilateral triangle. Okay, so let's take a look at each of these. take a minute, pause the video, write them down, and then check back with me. This first one, right angle, right triangle. We have two congruent sides, so that is an isosceles. We are classifying both by angles and sides. Okay, so first up on number 10, we have an obtuse. And I don't have any congruency markings on this, so we have to assume that none of these are the same, so that's going to be a scalene. All three sides are different. In number 11, we have three equal angles, so this is equiangular. And we also have three congruent sides, so it's also equilateral. In number 12, let's see, we have a 15, an 18, and a 20. This is a scalene. All three sides are different. And if we're looking at these angles, these are all acute angles. They are less than 90. In 13, we have a right scalene. And in 14, well, that's an obtuse angle, greater than 90. But two of our sides are congruent, so this is isosceles. Question number 15. Okay, well, let's read the directions. It says PR bisects this angle, SRT. SRT. So I know that this angle and this angle are congruent. If PR bisects, when you bisect something, you cut it exactly in half. If we have a 30 degree at the top, we're going to have a 30 degree right here. U is the midpoint of RT. U is the midpoint of RT. Well, that means if this section is 8, this section is also 8. If you're the midpoint, you're exactly in the middle. Classify each triangle by its angles and sides. Okay, UQR. Let's take a look at that. U to Q to R. All right, we're looking at this triangle here. I can see that it's got an obtuse angle and it's got two congruent sides. So this is an obtuse isosceles. RST. R to S to T. That's this big triangle here. All right, let's look at these side links. From R to S, we've got 16. From S to T, we also have 16, 8 and 8. From T to R, we also have 16. So this was an equilateral. Look at the angles. We've got 60, 60, 60. This is equiangular, equilateral. SRQ is the next one. S to R to Q. Okay, that's this guy right here. This is a right triangle, and we can see we've got different measurements for the sides. So we have a right scalene. PRT is next up. P to R to T. That's this triangle on the bottom. All right, so let's see, what do we have here? Well, this angle at T is going to be an obtuse angle because this is running perpendicular, and since this is 16 and this is 16, it's bisecting this angle, so we know that this guy is 60 also. 16 and 16 over here, so we know that this has two sides congruent. This is an obtuse isosceles. TUQ is up next. So T to U to Q. That's this little guy right in here. Hey, it's got these three congruency marks. This is 8. This was 8 because it was the midpoint and it was congruent to this segment. This is an equiangular, equilateral. We can also identify these are a linear pair, so this has got to be 60, 60, 60, and 60. Equiangular, equilateral. PQT, last step. P to Q to T. All right, well, we've got a vertical angle here. So we know at this corner we have a right angle from P to Q to T. Okay, I've got 8 here, I've got 16 here. This is going to be a different measurement. So I have a scalene right, or a right scalene. Okay, a couple more problems. We want to classify these in the coordinate plane, and so we're going to need to use the distance formula. So the distance formula is square root x2 minus x1 squared plus y2 minus y1 squared. So I'm going to go ahead and make a quick sketch of this guy. And I'm just seriously making a very quick sketch. It looks like J is -7, -7, K is -9, 1, and L is -1, -1. So I've kind of got this figure over here, and I'm just doing a very rough sketch of this. But if I do this, then I can see the sides that I need to measure. So let's start with JK. X1, Y1, x2, y2. Okay, so let's plug it into our distance formula. This is going to give me -9 minus -7 squared plus 1 minus -7 squared. And let's see, -9 plus 7 is -2 squared is 4. 1 plus 7 is 8 squared is 64. And so this gives me the square root of 68. And I'm just going to leave it like that. I'm not really too concerned with the square root. Okay, so this is going to be square root of 68. Now let's do K to L. Okay, so I'm going to go ahead and label these guys. So from K to L, and if I plug it into my distance formula, x2 minus x1 squared plus y2. Oops, I think I just did that backwards. It's okay, as long as you keep them in the same order. y1 minus y2. All right, so let's see what we have here. That's going to be 8 squared is 64 plus -2 squared is 4. And you can see that we are also getting 68. Okay, so let's try one last side, and that's going to be from J to L. All right, I've run out of room, so I'm going to go ahead and just do it down here. And let me go ahead and J to L. Let's renumber this guy, x2, y2. All right, so my last one is going to be, let's see, x2 minus x1. And again, it doesn't matter the order as long as you keep the coordinates, as long as you're subtracting the second from the first for both the x and the y, or the first from the second in both the x and the y, but don't switch them. So here I am subtracting. Let's see, I've got -7. That is my x2 minus my x1. So then I'm going to subtract y2 minus my y1. Okay, so let's see, that's a double negative, so that's going to be -6 squared, so that's 36. And that's also 36. And so that's the square root of 72. This guy is the square root of 72. Whoops. And so I can see that I have an equilateral. Oh, whoa, just kidding. If I have two sides congruent, my bad, that is an isosceles. All right, you would work the same setup with this next one. I'm going to go ahead and let you try it. If you do work it out, JK you'll find to equal the square root, I think, of 41. And JL is going to be the square root of 130. And then KL is going to be the square root of 85. When you have all three